Hi everybody, Mr. Market here again. In this video, I'm going to show you how to calculate compound interest when there are different compounding periods. My previous video looked at when we were compounding annually. In this video, I'm going to be looking at how we would do it if there were different compounding periods. I'm only going to go through two examples, but yeah, as long as you understand that if we're compounding interest half yearly, that's twice per year, monthly, that's 12 times per year, weekly, that's 52 times per year, quarterly, 4 times per year, fortnightly, 26 times per year, and daily is 365 times per year. Now, again, there is a formula you can use to calculate compound interest with different compounding periods. The difference between this one and the one I showed in the previous video is that you would divide your interest rate, which is already converted to a decimal, by the number of compounding periods per year, and you would raise it to Kn. So N being the number of years and K being the number of compound periods. So for example, if it was for 5 years and it was compounded quarterly, it would be 4 times 5 or 20, raised to the power of 20. Again, I won't be showing you how to use the formula as such because this is based, this video is based on helping my year 12s understand how to do compound interest, and of course they'll be allowed to use the graphics calculator in their test and the exam. So I'm going to be showing them how to do that within the financial function of that graphics calculator using the compound interest feature here. So the values will still be the same in terms of what we're putting into the graphics calculator, but there is a few slight differences in terms of how we would do that. N, remember, represents the number of compounding periods. So in my previous video, we just did N as the number of years because it was compounded yearly, once per year. So that gave us the number of compounding periods. If, like my previous example here, I was investing money for, let's say, 5 years, and it was compounded quarterly, so 4 times per year, the number of compounding periods in that case would be 20, okay? Not just the number of years. The interest rate will, again, remain the same when you're putting it on the graphics calculator. Just put in the interest rate as a percentage as they give it to you in the question. PV is, remember, the initial principal that you invest or borrow, or PV stands for present value. PMT, again, we won't be using in this video, but we will be looking at it next video. In the next video, we're looking at the future value of annuities. FV is the future value of the investment, and P/Y will be the number of payments per year, and C/Y will be the number of compounding periods per year. So in the example of compounded quarterly, interest will be paid 4 times per year, and interest will be compounded 4 times per year. So both P/Y and C/Y will be 4. Anyway, let's look at our first example here, which states I have $3,000 placed in an account which pays 5.2% per annum interest, compounded quarterly. Find the account balance after 5 years. Now, again, N is going to represent, as I just said, the number of compound periods. So if it's 5 years and it's compounded quarterly, it's 5 times 4, okay? In this case, it's 20. The interest rate I put into the calculator as a percentage, as 5.2. Don't convert that to a decimal. Look, if you were using the formula, you convert it to a decimal. But for the sake of this video, I'm showing you how to do it on a graphics calculator. Just put in 5.2. PV, the initial amount invested, or the principal, the present value, is 3,000. But again, because we are investing it, you're giving it to the bank, make that a minus amount, so minus 3,000. PMT, we won't be touching in this video. The future value is what we're being asked to work out, okay? And the difference here from my previous video is that P/Y and C/Y in this example are both going to be 4 because the interest will be paid 4 times per year and compounded 4 times per year. If it was the question asked me to what was compounded monthly, then those values would obviously be 12, and I would have done 5 times 12 to determine the number of values. But I'm using 4 here and 4 here because it's compounded quarterly, 4 times per year. So I'm just going to go and put that information into my graphics calculator. If it will allow me, yep. So F2 to access the compound interest function. I've already got stuff set up in here from my previous video, but again, we're just going to overwrite that. So n becomes 20, or if you want, you can just put in 5 times 4, hit execute, and it'll do the working out for you. The interest rate here is 5.2%, so you just pop in 5.2. Sorry, 5.2. The present value of the initial amount that we're investing, remember, is that minus amount, minus 3,000. The PMT, we're going to leave a 0 for the sake of this. The future value is what we're being asked to work out, so I'm just going to change it to 0 for this. And PY and CY will both be 4. So if I change one of them to 4, they should both change, but if I change payments per year to 4, then they'll both change to 4. Obviously not if I change CY. Anyway, I'm now asking it to calculate the future value based on all that information. So after 5 years, 5.2%, compounded quarterly, what will my initial principal on my present value of $3,000 be worth? Press F5 to determine the future value. It will then be worth $3,884.28. It's important again that we are rounding to the nearest cent here because we're talking about money. Okay, so $3,884.28 is going to be the future value of that investment. Okay. Now, the second example asks me to, in fact, if I can just get rid of that for now, asks me to this time determine how long that $15,000 must be invested for at 3.8% per annum to turn into $20,000 if it's compounded half yearly, if the interest is compounded half yearly, so twice per year. So again, I'm just going to, I guess, show those values that I'm going to put into my calculator. And in this case is what we're actually being asked to work out. Okay, keeping in mind that n isn't going to give me the number of years, n is going to give me the number of compounding periods. Okay, that's really important to understand. We'll touch on that when I get the answer. The interest rate, again, that gives it to me is 3.8%. Present value, or that initial principal that we're investing, is minus 15,000. Again, because we're investing it, we're giving it to the bank, it's a minus value. The future value, it tells us there is $20,000. That will be a positive value. And P/Y and C/Y will both be, in this case, because it's compounded half yearly, 2. Twice per year it's being compounded and paid into that account. So on my calculator, I'm going to put in those values. And let's just change that to 0 for the sake of this. Interest rate, let's change it to 3.8 as in the example. Present value, or that initial amount, is minus 15,000. PMT, let's leave it as 0. The future value, 20,000. Payments per year and compounding periods per year will both be 2. And I'm then going to ask it to calculate for me the value of n by pressing F1 here. And it tells me that n is approximately equal to, let's just do it to one decimal place, 15.3. So n equals 15.3. Now that's not 15.3 years, it's 15.3 compound periods. In this case, it's 15.3 half years. Okay, so what I'm actually going to do is I'm going to divide that number by 2 to actually tell me how many years. All right, so if it asks you how long must someone invest the money, it's probably not a good or a reasonable answer to give half years. You could give months or years and months, but I wouldn't probably leave my answer in half years. In fact, what I'll do is I'm actually just going to round that up to 16 and divide that by 2 and say it's 8 years. Okay, approximately. Obviously, it'll be less than that because I've rounded that 15.3 up to 16. But essentially, you get the idea that in approximately 8 years' time, the $15,000 invested at 3.8% compounded half yearly will turn into $20,000. Okay. Again, it's the same sort of process if you're being asked to determine the interest rate or the initial principal or the present value that is invested. You obviously then just put in the information that you have and ask it to calculate the interest for you or the present value for you. Sort of a little bit of backtracking rather than having to solve algebraically using this formula. Okay, of course you can use the formula, but hey, we've got access to the graphics calculator. You'll be allowed to use those in the test. So I think it's important to understand how to use that. Yes, sort of understand where it comes from and the formula you can use, but again, let's embrace the fact that we've got these graphics calculators and understand how to use them. So that's it for this video, calculating compound interest with different compound periods. Hopefully it helps, and thanks for watching.